let's go into a little bit more detail of these two functions, wait and signal, and let's see what happens inside them. What is their algorithm? First of all, let's see the wait function. Also, before that, let's see the initial value of s is usually always 1. So we always keep the initial value of the semaphore as 1. Keep that in mind. Now, what happens in the wait function? The wait function actually decrements the value of semaphore. So it decreases the value by 1, right? By one number, one integer number. And after decrementing the value of the semaphore variable, what we do is we check whether, what this function does is it checks whether this semaphore value after decrementing is positive or not. So if it is positive or equals to 0, the process is allowed to use the critical section. So in this case only, the process is allowed to use the critical section. It is allowed to enter in it, and it is not blocked. By saying that it is allowed to use the critical section, we mean that the process is not blocked. And if it is not positive, if it is less than 0, it is negative, then that process is blocked, or we can also say put to sleep. So that process is actually put in that queue we were talking about, the queue which we talked about here, this queue. So this process is actually put to sleep in that queue, which is actually blocked, until some other process comes and calls the signal function. Until then, this process is blocked, and after some other process calls the signal function, this process is selected to wake. Now, if you haven't understood this last line, this line until someone does a signal, if you haven't understood this line, ignore it for now and let's understand this signal function. After understanding it, you will understand this line better. Okay, what happens in the signal function? So signal function increments the semaphore variable by 1. And then after incrementing, it checks whether the semaphore is negative or equals to 0. If it is, it means that there is some process waiting in the queue. So there are some processes which are in the queue. So if there are some processes which are waiting in the queue, what happens is one process is selected and is waken up, and then the signal returns. And if there are no processes in the queue, that means this is not true. This condition is not true. That means there are no processes which are waiting in the queue or sleeping. Then that signal returns. Now, after understanding it, now you know that this signal function actually wakes up the process. So until someone calls a signal, this process which was blocked is not selected to wake up. Now let's try run these two functions and let's see what happens. So let's say there is a process P1, it came to use the critical section. So when P1 will come, keep in mind the structure of any process that has to use critical section. This is the structure. Any process that has to use critical section will enclose the critical section in wait and signal. So what that means, it will call the wait function first, and after using the critical section, it will call the signal function. So keeping that in mind, when P1 comes, it will definitely call the wait function. When it will call the wait function, it will as semaphore variable will be decremented. So right now the value of semaphore is 1. So after the wait function was called, its value became 0. Now let's see when the value becomes 0, let's see if this condition is true or not. If the value is positive or equals to 0, process is allowed to use the critical section. So in this case, this condition becomes true. When it becomes true, this process P1 is allowed to use the critical section. So it will enter in the critical section. Now P1 is using critical section. Now let's suppose another process P2 comes along to use the critical section. So let's write P2, and when it will come, it will again call the wait function, right? So when wait function is called, s will be decremented. Right now s equals to 0, so it means the s will become -1. Now when s becomes -1, let's again check this condition. Is it true? Is s greater than or equals to 0? No, this condition is now false. When this condition becomes false, it means this is true, obviously. So when this condition is true, when s is negative right now. So when this condition is true, then that process is blocked or put to sleep. So P2 will be blocked, it will be put to sleep in the queue. Now this process is actually blocked and it's waiting for the critical section to get empty. Now let's do it one more time, and let's suppose another process P3 also comes, so that you will understand better. Let's take this process. Let's take the example of this process too. So when P3 comes, again wait will be called and S will be decremented. Since it is -1 now, it will become -2. Again, after it becomes -2, this condition will be checked and obviously it is false. This condition is true. Again, P3 will be blocked and put to sleep. So these two processes are blocked right now and they are waiting for this critical section. Okay. Now, let's say P1 has done its work and when it will get out of the critical section, it will call the function signal. So when signal will be called, S will be incremented by 1. That means S is right now -2. And when it will be incremented by 1, it means it will become -1, right? And then this condition will be checked. If S is less than or equals to 0, it means some processes are waiting. And -1 is less than or equals to 0. This condition is true right now. And when it's true, we know some processes are waiting. And you know that P2 and P3 are waiting in the list. So when this condition is true, what happens? One process is selected and waken up. And then the signal returns. So this function, this signal will wake one process up to use the critical section and then it will return. So P1 has done the work, it's gone now, and now P2 is selected to use the critical section. So P2 is now using the critical section. And then after P2 is done too, it's done its work, again P2 will call the signal function. It will increment S by 1. That means now since S is -1 and you increment it, it becomes 0. Again, this condition is checked. If S is less than or equals to 0, if this condition is true, and we know this is true, S is 0 right now, it means again some processes are waiting and we know P3 is waiting. So it will be selected and it will be waken up and then the signal will return. Now P3 is selected and P3 is now using the critical section. So let's say P3 has done its work too. After completing its work, P3 will call this function signal and it will increment S by 1. Now let's increment 0. So when we increment it, it becomes 1. Now let's check this condition. This condition will be checked. Is semaphore less than or equals to 0? No, this condition is false now. Why? Because S is positive now. This condition does not hold true. So when this condition is not true, this means no process is waiting. So the signal will return. Right? So this is how this all will work. Since we know that semaphore is a synchronization variable that is used to synchronize two or more processes or threads to avoid the use of critical section at the same time. And what is critical section? Critical section is the common resource between which is accessible or shared between two or more processes or two or more threads. So that means we have to declare the variable semaphore also in a place which is common or accessible by all the threads of a process or all the processes. Why? Because it depends on the value of semaphore that whether a process or thread will use the critical section or not. So semaphore should be in a place which is accessible by all so that when its value is modified, it is accessible by all the process to see whether they can access the critical section or not. So to do that, there are two questions first. Which place, memory, or variable is common or accessible by all the threads of a process? What is the answer to this question? Which is a place which is common or accessible by all threads of a process? And actually, we covered this last week. We talked about this in the last week's videos. There is another question. Which place, memory, or variable is common or accessible by both parent and child processes? And we have covered this in the 7th week of our course operating system. So what is the answer of both these questions? I won't let you know right now. Think about them and comment them down below. Now let's see the implementation of semaphore.